Welcome back, it's Professor Ridge, and today's lesson on section 8.3, studying solutions of quadratic equations. So first we want to introduce this concept of discriminant. And the discriminant is the radicand of the quadratic formula. Okay, so specifically the b squared minus 4ac. Now, the reason we want to look at this is if I asked you 5 plus or minus square root of 49 divided by 2, square root of 49 is a perfect square, so that I give you 7. And then you get 5 plus 7 divided by 2, or 5 minus 7 divided by 2. So you would get 6 or -1. So see, you get two rational solutions. If the b squared minus 4ac was, say, 5 plus or minus square root of 13 divided by 2, well, that doesn't simplify, so you get these two answers. Which are irrational, so you get two irrational solutions. If the b squared minus 4ac was 0, you would get 5 halves, plus 0 is 5 halves, or 5 halves minus 0 divided by 2 is still 5 halves. So you get one rational solution that's repeated. So you get one solution twice, basically. And normally you just write down just one. Alright, and then the other case could be if the radicand was a negative number. And it doesn't matter if it's perfect square or not, because if you had a negative number, that's going to give you two imaginary solutions. Alright, so we can kind of put this in the chart. Okay, so again, if you get 0 for your discriminant, the b squared minus 4ac, the thing that's under the square root, that's going to cause you to get one solution, and that solution is going to be a rational number. If we got a positive number under the square root, that's going to give you two different real number solutions. And it breaks down into two cases that I showed you above. If it's positive and a perfect square, meaning like 49, square root of 49 is 7, square root of 25 is 5. So a perfect square, meaning that you can square root it, then the solutions will be rational numbers. If it's not a perfect square, then the solutions are irrational. So the square root doesn't go away, so it's irrational. And then if it's negative, we know that you're going to get two imaginary solutions, two different imaginary solutions. and we'll put a little quotes here, they're actually going to be complex conjugates because one's going to be plus, another one's going to be minus in the middle. A plus BI, the other one would be A minus BI. Okay, so for each equation, determine what type of number the solutions are and how many solutions exist. So basically, you're just going to figure out what b squared minus 4ac is, the discriminant, and use that chart that I just wrote above. So let's see. X squared minus 5x plus 3 equals 0. So it's in standard form. So a is 1, b is negative 5, c is 3. b squared minus 4ac is going to be 25 minus 12, which is 13. This is not a perfect square. It's positive and not a perfect square. So that means you get two irrational solutions. And that's all there is to it. So just basically figure out the discriminant. First make sure it's in standard form, figure out the discriminant, and then you can answer the question. So let's try number 24. So we got 3a squared plus 5 equals negative 7a. So we're going to add 7a to both sides. So we get it in standard form. And so the discriminant, a is 3, not the a is the variable, a is in the quadratic formula. B is 7, c is 5. So b squared minus 4ac is equal to 49 minus 3 times, or 4 times 3 times 5, 60. So that's negative 11, which is negative. So that tells me what? So look at the chart up there, that tells you get two imaginary solutions. And they're complex conjugates of each other. Okay, so the next topic in this section is you want to write a quadratic equation given the solutions. So if I tell you the solutions, can you work backwards and tell me a quadratic equation that has those solutions? So let's just review real quick. The method we learned in Chapter 5 for solving quadratic equations was you get it equal to 0, you factor it, facts 4 that add to 5, 4 and 1, both negative. You set each factor equal to 0, and then you solve them separately. So x equals 4, or x equals 1. So here we're going to work backwards and go that way. So we're going to start with the numbers. We're going to get them both equal to 0, so you subtract them. Then you're going to write them in factors equal to 0, and then you're going to FOIL it out and get the original problem. So we're going to start with x equals negative 2, or x equals 8. So we're going to add 2 to both sides. X plus 2 equals 0. X minus 8 equals 0. Then we're going to put it together. X minus 2, x minus 8. Oh, I'm sorry, that should be plus 2, right? Equals 0. We're going to FOIL it, so we're going to get x squared minus 8x plus 2x minus 16 equals 0. Then combine your like terms. And this quadratic equation has solutions that are negative 2 and 8. Okay, so let's try number 43. This one usually gives people challenges. 2 square root of 5 and negative 2 square root of 5. So I'm going to skip these two steps here and just start right there. So we're going to remember it's going to be x minus 2 square root of 5, x minus a minus, which is plus 2 square root of 5 equals 0. Then we're going to FOIL this. So that, well, that's a different square. So it's x squared minus 2 square root of 5 squared. So it's x squared. So it's going to be 2 squared square root of 5 squared. So that's 4 times 5, which is 20. Alright, that one wasn't so bad. X squared minus 20. Let's try number 48. So we got 5 minus 2i and 5 plus 2i. Now, I could have just given you 1 because we know there's a theorem that says that imaginary solutions always come in conjugate pairs. In fact, we talked about that. We put it in parentheses on a little chart for the discriminant. You get 2 different complex conjugates. I mean imaginary numbers, and then in parentheses I put their let me look at it, complex conjugates, right? So they always come in pairs like that. Anyway, you can do x minus 5 minus 2i, x minus 5 plus 2i, 5 plus 2i is in parentheses, 0. Now what I'm going to do is distribute that minus sign. And then I'm going to view it as the x minus 5 in parentheses that way. And now I'm going to view it this as a difference of squares again. Okay, so 2i squared it becomes 4i squared. 2i in parentheses squared becomes 4i squared, and the I squared makes it the negative become a positive. And then I'm going to use my a plus b squared formula, which is a squared plus 2ab plus b squared. So it's going to be x squared minus 10x plus 25. And if you forget it, just FOIL it. No big deal. X minus 5 times x minus 5. We're going to combine like terms. So I get x squared minus 10x plus 29 equals 0. And then you can extend this with 3 terms too. So if we look at 56, we got negative 2, 2, and 3. So we're going to go to x minus 2, which is plus 2, x minus 2, x minus 3. Okay, so I'm going to multiply the first 2. That's just a difference of squares. X squared minus 4, x minus 3. Now I'm going to distribute. So x squared times x is x cubed minus 3x squared minus 4x squared plus 12 equals 0. Oh, this is not x squared. This is just x. Sorry. So 4 times x and 4 times 3. All right. And so that's my answer. Let me write it again. X cubed minus 3x squared minus 4x plus 12 equals 0. Alright, so that completes the exercises, the section 8.3. Go to My Math Lab, complete your exercises there, and I'll see you next time.